Today we're going to talk about what a piecewise function is. So this is our introduction. So given a value of x, we're going to identify which piece, the piecewise function, we should use to evaluate. We're going to also evaluate the piecewise functions given a graph and given an equation. So we're going to do both. This is a no calculator section. So here's our entrance slip. It says, given each value of x, determine which inequality, A, B, C, or D, the value belongs. So in number 1, we have -8. So you're trying to figure out if -8 fits into A, B, C, or D. In number 2, we have the number 2. In number 3, we have -3. And then in the number 4, we have 9. So go ahead and figure out where does each number fall into, A, B, C, or D. I'm going to go ahead and pause this and go ahead and pause your screen too, and I'll show you the answers. So you should have gotten A, B, B, D. So -8 is smaller than -7. Number 2, the number 2 fits into -7 and 3. It's in between those two. For number 3, -3 also fits in between -7 and 3. And then in number 4, we have the number 9. 9 is larger than 7, so it fits into D. So what is a piecewise function? So a piecewise function is a function and just like the word piece, it splits up into different pieces. That's what this piecewise function does. So it fits into multiple pieces, but it's all based on these inequalities. And you can replace the word inequalities with intervals if you prefer. So it splits up into different equalities or intervals. So in number 1, this is an example of a piecewise function. Now we have 1, 2, 3, 4 lines, and this all connects to each other, making it one function. So we could call this function f of x, the line. The name is f. Okay, so we're going to figure out for f of -8 which piece it resides in, A, B, C, or D. So this is an x value, -8. So I'm going to go to the graph and we're going to look, okay, at -8, where's -8? And it looks like it resides in piece A. Then we have f of 2. So once again, this is an x value. So we're looking for when x is 2, do we have an answer? So when x is 2, right here. And that is in piece C. Then we have f of 3. So again, x value. So we're looking for f of -3. f of -3 is in piece B. And then finally, we have f of 9. So again, it's an x value. So we're going to go to what x is 9, and that is in part D. We're going to skip the undefined part right now and go ahead and try number 2. So you're just going to figure out where each x value resides for function f of x. Go ahead and pause the video and fill this out. So f of 9 is in piece D. f of -4 is in piece B over here. f of 2 is in piece C. And then finally, f of -8 is in piece A. All right. So then we have these undefined. So this is an interval. When it says from -10 to 10, that's an interval. And we're trying to figure out where is f of x undefined at. So actually there are multiple places that is undefined. And the first place that something can be undefined is at a hole. So I'm trying to look for holes in the graph. Now in number 1, I have 2 holes in the graph, and they're represented with open circles. So we could say that x is equal to, and right here at this first hole, that's at x equals 0, and at the second hole, we're at x equals 4. So those are the 2 places where it's undefined, and these are holes. So check out number 2 and go ahead and pause the video and write down where you think the holes are for number 2. So once again, we have 2 holes. One of the holes is at x equals -6 and the other hole is at x equals 5. So it is undefined at these two places because these are holes in the graph. Okay, so that is how we figure out all that we did was figure out where each x value resided in. In this next page, we're going to actually evaluate. So we're going to, we could think of this as A, B, and C for each piece, but we're going to figure out, given x, what's y. That's how functions work. Given x, what's y. So for number 3, we have f of negative 2. So I'm going to go to when x is negative 2, and I'm going to put a dot on the line. So at f of negative 2, we have an answer of negative 2. All right, then I'm going to skip f of negative 5. All right, we're going to go to f of 2. So in f of 2, we're going to go up until we hit the line, and we're at the number 6. All right, then we have f of negative 8. So we're going to go to when x is negative 8, and we're going to go down to the line. Notice I'm putting points everywhere, so my answer is negative 4. Okay, so I told you to skip f of negative 5 because if you check out f of negative 5, or when x is negative 5, it's right here. So that means that everything in this whole piece is negative 5. That's when x is negative 5. Well, in one of them we have a point, and then in the other one we have an open circle. Okay, so the open circle, remember like earlier, those are holes in the graph. So we're not going to use this as our answer. So we don't have, so it's not negative 8 because that's a hole. We need a point, and the point is going to be that closed circle. So my answer is actually negative 1. All right, so for this problem number 3, we don't have any holes in the graph, all right? This negative 5, x equals negative 5, it's compensated because we have a point at negative 5, negative 1. So that's not a hole. Another time that we could have something undefined is when we have a gap, okay? And there's actually a gap right here. So we have a gap in this entire section. Okay, so since we have a gap in this section, that's another place where it's undefined because we don't have an exact answer for like f of 4 or f of 5. So those would be undefined answers. So we're going to say that we have this is an interval. We're going to write this in interval notation. So we're going to write down the numbers 3, 6. Okay, and this is a gap. Okay, so notice that at the number at 3, all right, we have an open circle. Open circles get represented with brackets, and then at 6 we have a closed circle or a point, and that gets represented with a parentheses. So this is the correct way of writing that between 3 and 6 we have a gap. It's undefined, so we know that it's definitely undefined at the number 3, and then at 6 it's actually defined, all right? We have an answer for 6 because it's a point, so that's why we have that parentheses right there. So this is taken into consideration that we have a hole at 3 and a gap starting at 3 going all the way to 6. Okay, so up until now we've had all graphs. Let's talk about the 2 places that we had undefined. So we were undefined. Anything that's undefined is because we have a hole or we have a gap. Okay, so when we have a hole in the graph, you can either have that represented with a open circle, or when you get down below, you're going to see these inequalities, and it's going to have the less than or greater than symbol. Anytime that we have a hole, we're always going to put x equals. All right, because we have one specific number, so we have x equals. For a gap, whenever there's a gap, we're always going to put an interval. And the interval is based on x values, so we're going to put either brackets or we're going to put parentheses. Now we put brackets whenever we have an open circle and a graph, or if we're just given a function, you'll see it's less than or greater than. We have parentheses whenever there's a closed circle. Closed circles are with that equal sign, so we have either less than or equal to or greater than or equal to.